Again, I've cleaned up what was on this slide and gone back and written the formula that we're going to be using here to find the region that's common to both of these limacons here. Remember that we have one region squared minus the other region squared. We found that our limits of integration are pi over 4 to 5 pi over 4. So this is going to look like 1/2 times the integral. Our lower limit of integration is pi over 4. Our upper limit of integration is 5 pi over 4. We're going to have our r sub 1, we called this r sub 1, we called this r sub 2, and that's how we've got them in our calculator. So 3 minus 2 sine of theta quantity squared minus 3 minus 2 cosine of theta quantity squared d theta. Now, one like this, I'm just almost certain would be a calculator active question. There's a lot to do there by hand. And the main thing I think that they're after is, can you find your limits of integration and set up your integral correctly? So let's go back to our calculator. We have this function in R1, this function in R2. So we're going to go back here. We hit math. We choose number 9, and that brings this up. We are going to have our lower limit of integration was pi over 4. We said our upper limit of integration was, let's do this, 5, we'll do parentheses, times pi over 4. I'm a big advocate of putting parentheses everywhere. And so again, I'm going to put parentheses around R1, and to get R1 on the screen, we hit our variables button. I'm going to hit my right arrow and go over to y variables, but I'm in polar variables, so I'm going to hit my down arrow to highlight polar and then choose enter, and choose enter again, and that's going to put R1 in there. I'm going to close the parentheses around R1 and square that, and then minus, open another parentheses and repeat that process, but this time choose r sub 2, hit enter. I choose r sub 2, close parentheses, and I'm going to square that. Then hit my right arrow, and I'm doing things with respect to theta. So there's the integral that we had written on our screen. Now notice that there's something missing here, and what's missing is the 1/2 out front. Also, something interesting happens here because I'm given a negative value. That doesn't mean this is incorrect or I've done anything incorrectly. It's just integrating from pi over 4 to 5 pi over 4. And in context, we're talking about area of a region in the plane. Now, we only need half of this, so I would divide that by 2. And so here's the value that I'm after. I would be accurate to 3 decimal places, but I would give it as a positive value. So I would write 16.9705, and so that would be 16.9705 is the actual area of the region common to both of those limacons. Again, you have to remember context. Your calculator can only do algebraically or numerically what you tell it to do, and it's adding up areas of sectors, and it does it in such a way that it actually gives you a negative value, but in this context you're going to give a positive value as your answer. All right, so that finishes up quite a few videos here for area of a polar region, but there was a lot of information to cover there. So make sure you have detailed notes. You might want to slow down and go through these videos maybe a little bit slower. Make sure you flesh your notes out really well. Work on finding your limits of integration. Work on making sure that you have your 1/2 in front of your integral. Your alpha and beta values are theta values. That's your independent variable. But come to class next time and we'll work some examples.